Okay, homework number 7. Here's where we get into some complicated equations, really. It's just some of the practice of the hardest stuff we've done so far. And the reason why the thing that makes this hard is you have a fairly complicated least common denominator. You've got denominators, so you got to get rid of them, and you got to find the least common denominator. Now, to find the least common denominator, the first thing you got to do is you got to factor this thing over here, because you got to look at its roots. You got to look at its terms. So to factor this is just something we did back in class 4, I think it was. You put it into two monomial terms. Okay, x and x. Now we need two numbers. This is a negative, so this is going to be positive and negative. We need two numbers that are going to add up to positive 1 because the middle term is positive x, which is positive 1x. And the last term is negative 6. And if you think about it, the only possibilities are 3 and 2. Positive 3 and negative 2. Now the good news is that those are also the terms underneath the denominators for here. So the LCD, the least common denominator, is x plus 3 times x minus 2 because this whole term, this whole x plus 3 times x minus 2 will actually divide into each term. So let's try to do it with term number 1. Now with term number 1, and let's do this in different colors so it makes sense. For term number 1, x plus 3 cancels out with the x plus 3, which means the only thing you have left is the x minus 2. So it's 6, the top, times the x minus 2. In other words, it's this whole term times this whole term, but the x plus 3's canceled out. So this term is left with 6 times x minus 2. The second term, and we'll use a different color. This time it's the x minus 2 that cancels with the x minus 2, and you're left with only the x plus 3. So it becomes 5 times x plus 3. On the other side, well, you got x plus 3 cancels with x plus 3, and x minus 2 cancels with x minus 2, and you're left with simply negative 20 on top. And from here, it becomes much easier. From here, just distribute and multiply and solve. 6x minus 6 times 2 is minus 12. Minus 5 times x, negative 5x. Minus 5 times positive 3, negative 15, equals negative 20. Combine what you can combine. X minus 5x is x. Negative 12 minus 15 is negative 27, equals negative 20. To isolate x, simply add 27 to get rid of the other term. Add 27. And x equals negative 20 plus 27, which is plain old 7. Let's apply the same logic to question number 2. Well, okay, we got an x and an x. Again, we're factoring. This is a negative, which means we know that the signs are going to be positive and negative. Now we need two that are going to add up to negative 2 and multiply up to negative 8. And if you think about it, the only ones that make sense, once again, are 4 and 2, with the 4 being the negative. Negative 4 and 2 add up to negative 2, and they multiply up to negative 8, which means, similar to the previous question, the LCD is x plus 2 times x minus 4, because this will go into all of the other terms. Thankfully, these other two terms have the same expressions as the one underneath this fraction. Okay, so for the first one, the x minus 4 is going to cancel with the x minus 4, which means you've got the x plus 2, and you got 1 times x plus 2, which is just plain x plus 2. For the second term, you've got the x plus 2 canceling the x plus 2. The x minus 4 is the only one left, so you've got 5 times x minus 4. And on the other side, the whole thing cancels, so you've got just plain 6, because this cancels with this, and this cancels with this. Now let's distribute this parentheses. So you've got x plus 2, negative 5x, minus 5 times 4 is positive 20, equals 6. Let's combine. X minus 5x is negative 4x. And positive 2 plus 20 is positive 22, equals 6. Subtract 22 from each side, and you have negative 4x equals 6 minus 22, which is negative 16. Divide each side by negative 4 in order to isolate the x. Divide this side by negative 4, and x equals negative 16 divided by negative 4, which of course turns out to be positive 4. You know, let's check it. Why not? You know, let's just make sure. We got 1 over, well, that doesn't work because then this is going to be a 0. So I guess just like we saw earlier in the course, that would actually not work, even though it is the answer. I mean, that's the answer that we got from solving it, but as it turns out, the whole equation isn't going to work because it's going to check as a denominator of 0. Number 3 is a little harder in that you have different terms on the different denominators. Now, we can still factor a little bit. You always want to try to factor everything. This obviously can't be factored. It's already in its simplest term. This can't be factored, but 2x plus 6 can be factored into 2 times x plus 3. You see why I'm doing that? I'm doing that because this I want to be similar to this. So our LCD, what will divide into everything? Well, first of all, you need a 2 times x plus 3, because that's necessary to divide into this fraction. But you also need the x minus 2. So this is actually the least common denominator. You have to divide, you have to multiply this whole thing by every term, because the x minus 2 is necessary to cancel out this, the x plus 3 is necessary to cancel out with this, and the 2 is necessary to cancel out with this. So now we're going to have to multiply this by each of the others. You know, if I had more room, maybe I'd do them separately, but let's just use different colors like we did last time. Okay, so the first term, the x plus 3 cancels with the x plus 3. And what do you got left? You got the 2 times x minus 2. So this is 3 times, I'll use a dot, 2 times x minus 2. Okay. Now let's use, for the middle one, well, the 2 times x plus 3 wipes out the 2 times x plus 3, and the only thing you got left is the x minus 2. So you've got 5, which is the numerator, times x minus 2, plus, now you got the last thing over here, and we'll use purple, I guess. The x minus 2 wipes out the x minus 2, but you still have the 2 times x plus 3. So I'll put this as 2 times x plus 3. All right, once you have this, you can solve it like you would any other equation. First of all, of course, 3 times 2 is 6. Well, you can open up parentheses first, but it really doesn't matter because this is multiplication, so you can make this into a 6. So 6 times x is 6x minus 6 times 2, which is 12, equals, open up this parentheses, 5x minus 5 times 2, which is 10, plus 2 times x is 2x, plus 2 times 3, which is 6. And now combine them all. Well, on this side, you got nothing to combine yet. On that side, you got 5x plus 2x is 7x. Negative 10 plus 6 is negative 4. Now, let's say we can subtract 7x from this side and 7x from that side, and add 12 to this side and 12 to that side. So you've got negative 1x equals negative 4 plus 12, which is positive 8. And you can divide or multiply by negative 1 in order to get x into positive. Basically, you just got to flip the signs, and this becomes negative 8. Completing the square is a method for solving quadratic equations that we didn't discuss much before. I've done it in the other video, but we didn't do it when we were discussing the previous homework on quadratic equations. But this is a mechanism by which we try to solve an equation, not necessarily by using the quadratic formula, which is pretty complicated, and it's a situation where you can't factor. If you can factor, then just do that. Obviously, that's much simpler. But completing the square is a way that we get it so that whatever's on this side, whatever's on the quadratic side, will become two monomials that are the same. Or in other words, two binomials that are the same, two binomials that are squared. And that will allow us to use the square root property in order to get the answer. So, for example, over here, what you need to do is really just take 1/2 of whatever this coefficient is, 1/2 of that, and multiply it by 2, and make whatever is multiplied by 2. Take 1/2 of that, not multiply it by 2, square it, square it, and then you make sure that number's over there. So 1/2 of -8 is -4. -4 squared equals 16. So if 16 is over here, then we know we're going to be able to divide it into two binomials that are the same as each other. Let's show you how. First of all, if we had x squared minus 8x plus 16, watch how we could factor that. We could obviously do x and x. Because this is positive and this is negative, they're both negative. And of course, 16 is 4, and 4 times 4, and -8 is -4 plus 4. So they both become 4s. Obviously, that's what will always happen. If you take half of this and you square it and put that over here, by definition, it has to be two of the same binomials. And once you do that, by the way, the whole point of this is x minus 4 times x minus 4 is the same as x minus 4 squared. And that makes it a lot easier to use the square root property, as we'll see. So first of all, how do we get this to be a 16? Well, that's easy enough. Just add 11, right? And if you add 11, you can do that. Remember, you can do that in any algebraic equation as long as you do it to the other side too. You do it to this side, so do it to that side. Now we've got x squared minus 8x plus 16 equals 11. This can now be factored into x minus 4 times x minus 4, which we did on the other side, equals 11. This, of course, becomes x minus 4 squared. Same thing, same exact expression. In order to get rid of a square, all we have to do is take the square root of the whole thing, right? Take the square root of this whole thing, take the square root of this whole thing, and you've got x minus 4, because the square root of something squared is just that, equals square root of 11. And to isolate x, just simply add 4 to each side, and x equals the square root of 11 plus 4. The point of doing this is that if we use the quadratic formula, remember that negative b plus minus square root of b squared minus 4ac all over 2a, we get the same answer, but this is a little simpler. You know, once you can get past that initial hurdle of making sure that you know what to get over here, then using the square root property is going to be a lot easier than applying the quadratic formula. This is a complicated one, a little bit of a tricky one, probably more complex than anything you're going to see on the exam, but I think it's still good practice if you've looked at it and tried to figure out what to do, how to go about doing this. Well, whenever you talk about a quadratic, there's cubes and all that, but the first thing you always want to try to do for these kinds of things is see if you can factor anything out of all terms. And in this case, you can. You can factor something out of here, and that is you can factor an x squared out of each one. So you can say, for example, x squared times, and then this becomes 3x, and the other side becomes 2. You can factor out 3x, x squared out of each one because there are at least 2 x's in each term. And on this side, you can factor out, well, let's see, you can factor out 4 from each one. So because each thing can be divided by 4. 12 divided by 3 is 12 divided by 4 is 3, so this term becomes 3x, and this term becomes 2. I think you see right away that how this problem works, how this problem is going to tick, because you've got a 3x plus 2 on each side. Now, as with any quadratic equation, you want to set the whole thing equal to 0. So how can you set the whole thing equal to 0? The answer is you can subtract this entire term. Minus 4 times 3x plus 2 from this side, and minus 4 times 3x plus 2 on this side. Now the interesting thing here is that because the x squared and the 4 have the same variable, in other words, they both have a 3x plus 2 next to it, you can change this is really the key to the question, into x squared minus 4 times 3x plus 2. It might take a little while to think of, and first of course, this side becomes 0 because it's minusing the same thing as the original term. It might take a little while to think of why that is, but if you think about it logically, it makes a lot of sense because let's say you have 3x plus 4x. We know that's 7x because they have the same variable, that x. So let's say you have xy plus 3y, well, you can change that into, let's say, x plus 3 times y, because it's just the same variable, but you're adding. So x plus 3y. That's the same thing here. X squared times this minus 4 times this is the same thing as x squared minus 4 times this. Now, this can be further factored. X squared is the difference of two squares, with a missing middle term. So this is the same thing as x plus 2 times x minus 2, still times 3x plus 2 equals 0. Now, this time in a quadratic equation, we actually have three different possible answers. Any of these becoming 0 is going to make the whole thing 0, so we can actually divide this into three different sections. We can set x plus 2 equal to 0. We could set x minus 2 equal to 0. And we could set 3x plus 2 equal to 0. And for each one, we can get a different answer. Subtract 2 from each side, and we've got x equals minus 2. Add 2 to each side, and we've got x equals positive 2. And then subtract 2 from each side, and we've got 3x equals negative 2. And then divide each side by 3 to isolate the x. And we've got x equals negative 2/3. Any of these three answers will actually work if you plug it into the original equation up here. I don't know if I want to try this one over here, because that's going to be really complicated. If we try the 2's, well, 2 cubed is 8. 3 times 8 is 24. 24 plus 24, well, 2 squared is 4, plus 8 equals 12 times 2, which is 24, plus 8, which is obviously the same terms. If you do it with a negative 2, it's going to be the exact same thing, because negative 2 cubed or negative 2 squared is going to be a, well, actually, they're going to be a little different, but they're going to work. If we do a negative 2, so let's use a different color. If we do a negative 2, so negative 2 cubed is negative 8. Negative 8 times 3 is negative 24. Plus 2, negative 2 squared is positive 8. Positive 4 times 2, which is positive 8. Then 12 times negative 2 is negative 24 plus 8. And again, obviously, these two sides are the same thing. And if you did it with negative 2/3, it would work as well. But that, again, you're just going to have to take my word for it. Okay, let's try our last homework for this set, for number 7. That's the square root of x plus 3 equals x minus 3. Seems simple enough. Well, how do we get rid of a square root? Well, in equations, whenever you're doing one thing, you want to get rid of it, you just do the opposite. So what if we say the whole term squared? Well, the square root of something squared is the original term itself. Whatever you do to one side, you do to the other. So now we've got the square root of x plus 3 squared, which is just plain old x plus 3, equals x minus 3 squared, which means x minus 3 times x minus 3. This is going to be a quadratic equation because you have to multiply it out. No way you can solve this off the bat. You got to multiply the x minus 3 out and then set the whole thing equal to 0 and work on it that way. So do the FOIL. X times x is x squared. Negative 3x is minus 6x. Again, the outer is negative 3 times x is negative 3x. Inner is negative 3x again. So that's negative 6x altogether. Positive 9 for the last. Okay. Well, now it's a quadratic equation, so let's set the whole thing equal to 0. So let's subtract an x from this side and subtract a 3 from this side to cancel them. So we'll subtract an x from here and subtract a 3 from here. And let's do the opposite side, just to make it look a little bit more normal. On this side, we'll do the x squared. Minus 6x minus x is negative 7x. Let's see, this is positive 6 equals 0. Now, does this factor? It looks to me like it does factor, just off the top of my head. We've got an x and an x, and we've got a positive here and a negative here, which means both of these have to be negative. And it looks like 6 and 1 will work, because 6 and 1 multiply up to positive 6, and 6 and 1 add up when they're both negative to, of course, negative 7. Set each equal to 0. And on this side, x equals 6. And on this side, x equals 1. And there you have it.